So our next lesson is really a sub-lesson of using bonding capacity to put molecules together. The number one strategy you're going to use is bonding capacity. Carbon has 4 bonds, oxygen has 2, sulfur has 2, nitrogen has 3, hydrogen and the halogens have 1. Okay? That's based on Lewis theory, Lewis dot diagrams. It's a theory, it's not perfect. If you notice it fails, then you're going to move on to these 5 steps to predict. So one case where it's going to fail is if something has a charge. Bonding capacity, we never talked about how to deal with charges. Okay? So that's your number one thing you're going to get tested on. So if you have CO3 2- carbonate ion, okay, you're going to have to use these steps. They'll deal with that 2- charge and those 2 extra electrons. Okay? And then you'll also deal with examples where bonding capacity just doesn't work with SF6 that was mentioned in the previous video. You'd expect sulfur to have 2 bonds using bonding capacity, but we have 6 Fs. So this isn't going to work. Okay? We've got some d orbitals that are causing some extra bonding. You don't have to care about any of those orbitals, just know to use these steps. This is not an AP thing. Every student needs to be able to use these too. Okay? We just know why SF6 isn't working. It's because of d orbitals in the hybridization. The why you can know, that to do it is everybody's. So these are the steps we're going to go through. You do not have to memorize them in order. I just do them in my examples. I don't label them 1, 2, 3, 4, 5. Okay. This only works when there's one central atom and would work for any question that is one central atom. Just bonding capacity is way faster. You could do this with H2O, with oxygen in the middle. But why bother when you know O has 2 bonds, you connect the 2 H's, you're just done so fast. Okay? This would not work for C6H12, okay? Because C6 has 6 carbons in a row. It doesn't have one central atom, so it doesn't work. So when you have one central atom, you're going to add up all the valence electrons that you have in all the atoms. So that's the outermost electrons. The group tells you how many outer electrons it has. Okay? And then we're going to factor in the effect of the charge. If it's negative, we're going to add electrons. If it's positive, we're going to take some away. So I'm going to do SO3 as my example. If you try to use bonding capacity, sulfur should have 2 bonds, and you can't put 3 oxygens into 2 bonds. So bonding capacity doesn't work for this. We've got some d orbitals doing some bonding. That's why bonding capacity in Lewis theory won't work. So I've got sulfur atoms, I've got oxygen atoms to add up the valence electrons. So sulfur is in group 6, so that's going to contribute 6 electrons. Okay, only valence electrons are part of bonding. Oxygen is also in group 6, but there's 3 of them. It's SO3. And then there is no charge here, so I don't have to add or subtract any electrons from that. Okay? If it was negative, we would add that count. If it was positive, we'd take away. So we've got 6 and then 3 times 6. So that is 24 valence electrons to assign into our structures. Okay? We should always get even numbers, and we're going to put them as pairs of dots or dashes, pairs of electrons that are bonding. We're going to place the single atom in the middle, or if there's a tie, we're going to put the biggest bonding capacity atom in the middle. Here, it's SO3, so we're going to put that sulfur in the middle. Place single atom in the middle, surrounded by the other atoms. Connect all atoms to the central atom. So the O's are the outside atoms. Don't make fancy circles, okay, squares, triangles. Connect all atoms to the central atom. Connect, connect, connect. Okay. Every now and then I'll see some O to O connections. That's not what you do. realize every dash that I just used is 2 electrons. Okay? That's how we use dashes in chemistry for drawings. So I've finished step 2, central atom, connected everything, and I have to realize I have used up 6 of my 24 electrons in those 3 dashes. Okay? We're going to keep building on top of this structure. Okay? Complete the octets for all non-central atoms. So we're going to start on the outside and work our way in. Octets on the outside, we'll get octets in the middle, and then we'll be done. So I'm going to use my drawing above. Complete the octets in all non-central atoms, so that's my O. My bottom left O has 2 electrons around it already. 3, 4, 5, 6, 7, 8. There's an octet by putting in 6 more electrons, 3 lone pairs. And due to symmetry, we have the exact same outcome at all of the O's. I need 6 more there. I need 6 more there to get an octet. There's 6 red electrons and 2 blue around every one of the oxygen atoms. So that's done. Okay. Place any remaining electrons on the central atom. Well, let's count. Hopefully I haven't used up more. There's 24 electrons, 2, 4, 6. The blue one is 8, 10, 12, 14, 16, 18, 22, 18, 20, 22, 24. I've put in 24 electrons, and I only had 24. So all of my electrons have been accounted for. I have none left. Okay. Place any remaining electrons on the central atom. Well, that is 0. So I have 0 to add in. Okay. If I had 2 left, I'd put a lone pair in the middle. Okay. But in this case, I don't. If the central atom doesn't have an octet, transfer a lone pair from the central atom to bond with the central atom. So, do I have an octet in the middle? There are 3 blue dashes. Okay. 2, 4, 6 electrons. So I'm short 2 electrons, so I have to move a pair in. So one of the oxygen's lone pairs is incorrect. It needs to be a bonding pair. Okay. Now it doesn't matter which O you pull from. I'm going to pick this O and that pair. Okay. It doesn't matter. Okay. Okay. We'll talk about this tomorrow in resonance structures. There's actually 3 possibilities. So there's 3 different structures that you could draw to represent this. And the truth is the average of all 3. Okay? But you just need to pick one of the structures, and you're going to move that lone pair into a bonding pair position. I'm going to redraw this. So where I've moved that red pair with the green arrow, there's going to be 2 bonds there now, not just 1. So I had sulfur, oxygen, oxygen, oxygen. I'm using sort of O's or dots for my lone pairs. You can use X's or any symbol you want. This oxygen had 2 lone pairs that I didn't touch. But the 3rd lone pair, I moved it into a bonding pair, so I'm going to put a second bond. Now, all my atoms have octets. I didn't wreck oxygen's octet. I now have 2 dashes, which is 4 electrons, 2 lone pairs, which is another 4 electrons. So there's still 8 there. My sulfur has 4 dashes around it, so that's its octet. I'm not going to circle both other O's because they're the same. There's 6 dots and 1 dash, so 8 electrons there. So we have an octet there. So we have sulfur with a total of 4 different bonds around it. A double and 2 singles. Okay. So this is using the steps to predict the structure of SO3. Okay. So I'm going to do a couple more examples, and then you can keep practicing both using bonding capacity, which maybe 80 to 90% of your questions on exams will be bonding capacity. You'll have 1 or 2 without it. So you should budget your time mostly on the previous lesson, a little bit on this one. So I'm going to do carbonate, something that has a charge. As soon as you see the charge, there's no way bonding capacity will work. We can't do 4 bonds with carbon and it's to 3 O's. That wouldn't match up or work anyway, or likely wouldn't work. So you may want to have those 5 steps open in your notes or keep glancing at them. So you want to think of where do you start with ions or things that bonding capacity doesn't work, and it's counting the electrons first. So I've got carbon, I've got oxygen, and then I have to factor in the charge. So carbon is in group 4, so that's 4 electrons. There's 1 of them. I'm not going to write times 1. Oxygen is in group 6, so it has 6 valence. Okay, core electrons aren't part of bonding. We're not drawing any core electrons in our diagram. And there's 3 of those. And then we have a charge of 2 minus. This means 2 extra electrons were stolen from something or came from somewhere. We don't care where they came from, but we have to add 2 for those 2 minus. If it was plus 3, we would take 3 away. Okay. So for the charge, I'm going to add 2 more electrons. So we have 4, we have 18, and then we have 2. So this adds up to 24 valence electrons between the atom and the charge. Okay. Next step said put the single atom or the highest bonding capacity in the middle and connect everything to it. Then stepwise, I don't memorize the numbers. I memorize start on the outside, work our way in. So I've used 2, 4, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 electrons. I've got octets on 2/3. 19, 20, 21, 22, 23, 24. I just used up my last electron. And I got octets on the outside. Now I move to the middle. I have no lone pairs. I have no electrons left to add to the carbon. And I have to get an octet there. So I've got to move a lone pair from somewhere into a bonding pair position. So this example is quite similar to the previous one. So I'm going to redraw it carbon to an O, to an O, double bonded to an O. Okay. Now as a structural diagram, I wouldn't have to include all the dots. I'm going to leave them out. Central atom now has an octet. Now a couple different things we have to do. Same as with those dot diagrams for ions we did with ionic compounds. Because this has a charge, we've got to do that same type of process. You've got to square bracket your charge structures and put in the 2 minus. Okay. And I guess I've got the time. I'll throw in the lone pairs just in little dots. carbon has none in the middle. And that is the 5 steps done. I didn't label them. So I'll do, there's not many positive molecules, molecular ions, but this is one of the very few. Ammonium, ammonia is NH3, ammonium is NH4. And I can run through the steps quickly, so it makes a nice example. So we've got to count the valence electrons. So we've got nitrogen, we've got hydrogen, and then we've got we have that charge to factor in. Nitrogen is in group 5, and there's 1 of them. Hydrogen is in group 1, but then there's 4 of them. And then the charge is +1. So there was a loss of an electron to make this structure and became positive. So we have to subtract 1 electron because it's positive. We're removing 1. So our nitrogen contributed 5, our 4 H's contributed 4, so that's 9, but then it's positive, so that drops us down to 8 electrons. You must get even numbers. We never have odd number of electrons. Those would be unstable. So you get odd numbers, you recount. So we put the central atom in the middle. We connect everything to it. I have 4 dashes, so I've used up 8 electrons. I've used up all of the electrons. So then I'd start on the outside. I'm not going to get octets on the outside because hydrogen only wants 2. I'd get a duet. So the outside is good. I'd move to the inside. I have no electrons to add. So there's nothing to do there. And nitrogen has its octet. There's 4 dashes around it. So I'm almost done. I just have to deal with the bracketing piece. So a lot of students on a test will get here, feel comfortable, and stop. And they'll forget that this is a positive ion, and they won't square bracket it and put the charge. Now I'm complete. Tidy up my charge. Okay. So hopefully that's enough to get you through. Okay. There's a couple examples in your workbook you could work on. Before you do that, let's see if you could draw hydroxide. Can you do the count? Can you connect things together? Can you put in the dots properly? So hopefully you had a chance to work through this example. Electron count comes first. So O, H, and then factoring in the charge. So that'd be 6, 1, and then -1. Negative is an electron. Negative charges are extra electrons. So we have to add 1 electron. Now I didn't write, that's kind of a confusing way. That's adding an electron, not +1. So 6, 7 plus 1 more is 8 electrons. So we're going to start with, we don't really have a central atom. We only have 2 atoms. You can connect them up. You'd kind of want to think of the O as the central atom if you had to identify one. So start on the outside. There's kind of no distinctive outside, so we'll just do both outsides. O needs an octet. Now hydrogen doesn't want an octet, it just wants a duet because it's in group 1. So we have completed the outer energy level for both atoms, oxygen in period 2 with 8, hydrogen in period 1 with 2. We've used up all 8 electrons, 6 dots and a dash. Everything is stabilized, so we just have to square bracket and put in the minus. And we're good. Okay. So tomorrow we'll deal with A more complete answer to something like carbonate, okay, I pulled the lone pair from the right-hand side, but I could have pulled from the top or the right. I could have drawn 3 different answers, and the actual best answer is the average of all 3. Okay? That is an AP only topic. We'll do that and start heading towards our shapes tomorrow. Okay? But now you have all the skills you need to draw any structure you would need to draw in Chemistry 20.